اللي بعده. Next question. يلا read B. Who's gonna read? Yes.
The average salary of all assembly line employees at a certain car manufacturer is 33,000 per meter.
Why?
Because all the assembly line employees were included.
Right, because all assembly line employees were included in the study. C. Who's gonna read C? Yes.
The average late fee for 360 credit card holders was found to be $56.75.
Is 360 is all credit card holder or a sample? If sample is associated with what? Statistics. Okay. And you please do 3 for classwork because we don't have time. So we're gonna move on. You can do it now or you can do it later. It's up to you. Now I have here more. Go to the next one. And I need someone to read the entire paragraph. Who can read? Yes, please.
Identify population, sample, parameter, and statistics. A research company performed a study of Machiavellian policy, traits and accountants. I don't know, it's Machiavellian describes negative character traits that includes manipulation, cunning, duplicity, deception, and bad faith. A questionnaire was administered to a random sample of 800 accounting alumni of a large university. However, due to non-response and incomplete answers, only 256 questionnaires could be analyzed. Several variables were measured, including age, gender, level of education, income, job satisfaction score, and Machiavellian rating score. The research findings suggest that Machiavellian behavior is not required to achieve success in the accounting profession. Complete parts 1 through 6 below.
Okay, very good. Now we're gonna please read by itself, read the question and try to answer. Question number 1, what does it say?
By the population of interest.
Okay, what is the population of the interest? Is it all 256?
No.
Is it all alumni?
Yes.
Is it all accounting alumni? Is it the 800 accounting alumni? The answer is C. C is correct. C is correct. All accounting alumni of a large university. Okay. Now let's go for the next one, number 2. Who's going to read number 2? Yes.
Identify the sample. E, the sample is all alumni of a large university. F, the sample is the 800 accounting alumni who returned the questionnaire. G, the sample is all accounting alumni of a large university. H, the sample is the 256 accounting alumni who returned the questionnaire. I think it's H.
Yes, it's correct. It's H. Correct is the answer. H is correct because we are using sample of what? 256 accounting alumni who returned the questionnaire. Why F is not correct?
Because only 256 questionnaires could be analyzed.
Because 256 only
Answer.
alumni who returned the questionnaire. The remaining what did they do with the questionnaire? They put it in the garbage. All right, next question. Can you do the remaining one at home? Yes, okay. So I'll leave the remaining one for you to do it at home. Okay?
The question before, I didn't understand.
Which question?
Question 3.
Question number 3.
No, not this one. Yes.
Question number 3.
Anyone?
Yes. A or B or both?
ونختار انتم مو كاتب ان active population or sample or
Yeah, decide, is it population, okay, or sample? Is it population sample or population parameter or sample statistics? So let's read A. Go ahead, read A. Say in
USA Today internet poll, readers responded voluntarily to the question, do you consume at least one caffeinated beverage every day? What's the answer?
Okay, so I have to do population, that's number 1. Number 2, I'm going to have to identify the sample. Number 3, I have to identify the population parameter. And number 4, I have to identify the sample statistics. Okay, so what is the population here?
All USA Today.
Yes, so you're going to be writing population. And in front of population, you're going to say what? All readers of USA Today. It's a newspaper. Okay. What's after population? I finished with population. Second one is what? Sample, correct? What will be the sample here?
Voluntarily answer.
Voluntarily, yes. Volunteers, right? So those are the volunteers that responded to what? To the survey. Next one is going to be what? What's the next parameter?
Yes.
What's the parameter here?
Those who consume at least one.
Percent of what?
Of people
Of people who
consume at least one caffeinated beverage a day.
who have at least one caffeinated coffee needed to drink, like they drink coffee. Among who?
All of the readers.
Yes, all readers.
We have to write all this.
Yes, sir. Of what? What they read?
USA Today.
USA Today, the newspaper. One more. We finished with the parameters.
The sample statistics.
Sample statistics. What will be the sample statistics?
So,
Is the percent of what? Percent of people who what?
Drinking the
At least
coffee.
what? At least what?
At least one.
One caffeinated what?
Beverage a day. So the answers of the parameter and the sample statistic basically the same?
Among who what? Among
Pleasing.
those what? Who
Answer.
responded to what?
Four.
To what? To the survey. That's it. So do you see the difference now between sample statistics and parameter?
Yes. You can't be part of the sample.
Here, among all readers, but here, those who responded to the survey. See the difference? Is this clear?
Yes.
So you're going to have to do it how many times? You have to do it 4 times. 1 for the population, 2 for the sample, 3 for the parameter, and 4 for what? Sample statistics. Okay? So you have to do this also for letter B. Okay? Now let's go for conversion, right? Here, I will leave this to you based on the previous paragraph. Answer the following points: data, population, parameters, sample, statistics, and variable. I'll skip this. Now I go for try. Now you try decimal and percent. If I want to round up, if the number is 5 or 6 or 7 or 8, you round up. If this number is 4, 3, 2 or 1 or 0, you round down or you keep the same. For example, I have 0.55. It's 1 decimal place. So if you want to round this by decimal place, become 0.6. If it's 0.59, you round it. It's going to be 0.6. Okay. For example, I have here 0.54. If you need to round this, it become what? 0.5. If you have 0.51, round it, 1 decimal place, 0.5. Can you do this one now? Convert from decimal to what? To percent. Can you do it now? So what's the answer? You have to move it to how many? 2. So it's going to be point, 0, 5. What? Percent. Yalla, do this one. 0.005. How many places you have to move? 2. So where do you stop? 0.05. Here, 0.66. You move it how many? 1, 2, right? So it become what?
6.
166. 66%.
66%, correct. I just want to go back to this one, try it again, and this one as well. So I'm going to remove this and redo it again. We have the number 0.0005. I have to move how many? 2 places, right?
Yes.
So it's going to be 0.05. Here, 0.005. I have to move how many? 2. 1, 2. So it's going to be what? 5%.
That's the first answer was not correct.
Yes, the previous one was not correct. Now this one, I have to move how many? 2 places. So it's going to be 66. This one is going to be how much? 100%. Okay. Next one. Let's move to the next one. Write the decimal according to the requirements. 2 decimal place. I have to round it to 2 decimal place. So only do it 0.05. But this is 5, right? So this convert to what? 6. Correct. This one 0.66. 2 decimal place. The 4 You round up or keep the same?
Keep the same.
Keep the same. 0.045. He wants 3. But this is 6. This 6 will convert this to what?
0.46.
So it's going to be 0.46. Okay. Can you do the remaining one?
Yes.
Yalla, do the remaining one.
0.46 or 4.45.
0.46. Yes, correct. All right, so let's move on. And the answer is written here. Okay. Now we're going to go for frequency. Remember this I gave you at the beginning of the lesson? So I have here, how many 4s do you have? How many males in the class? 4. So you write down 4. How many female in the class? 6. So what is the relative frequency? The total is how much? So first you have to find 4 and 6, and then you add. So that's the first step. You get 10. 4 divided by 10? 0.4, which is 40%. 6 divided by 10? 0.6 or 60%. Now remember, 40% and 60% give you 100%. If you add 0.4 plus 0.6, give you what? 1. So it's either you use 1 or you use 100%. Both of them the same. Now remember, I told you cumulative frequency, relative frequency. You keep the first one the same, and then the next one you're going to add 0.4 plus 0.6, and the answer is what? 1. 1 consider as what? 100%. Clear? Can you do that? Okay, here is another example. I think this one is also easy, right? This at the beginning of the class. Now we're going to go for this example here. Can you please read the example? A baker.
The baker keeps track of how many free donuts his customers eat. 25 customers ate 1 donut, 15 customers ate 2 donuts, 7 customers ate 3 donuts, and 3 customers ate 4 donuts. Question. Create frequency distribution table. What percent ate between 2 and 3 donuts? How about what percent ate more than 3 donuts? What percent ate at most 3 donuts?
Okay, so let's make the table. Now, how many people eat 1 donut? Yeah, so here 1 donut, how many? 25. 2 donuts? 15. 3 donuts? 7. 4 donuts? 3. Their total is how much? 50. Now I will take 25 divided by the total. 25 by 50, how much it give you? 0.5, which is 0.50. Could be 0.50 or 0.5, the same thing. Next is going to be 15 divided by 50. They give you what? 0.3. 7 divided by 50? 0.14. 3 divided by 50? 0.06. The total must be what? 1. Now, cumulative. Cumulative يعني so the first one stayed the same. Second one, you have to add first plus the second. The third one, it has to be, you have to add the first plus the second plus the third. And the fourth one, you have to add what? All. The first, second, third, fourth. And the last one, their total has to be what?
1.
Total 1. If it doesn't come to 1, then you made a mistake. Clear, mister? Easy? Now, need to answer the question. What percent eats between 2 and 3 donuts? between 2 and 3 donuts?
44%.
Okay. How many eat $3? 3.3, right? For 2 donuts. 0.3 for 2 donuts. What about 3 donuts? 0.14. So when you add those together, 0.3 plus 0.14, the answer will be what? 0.44, which means what? 44% of the customers, they ate between 2 and 3 donuts. Is this clear? Okay. Next question. How about what percent ate more than 3? What percent they ate more than 3? More than 3 means what? 4. 4 donuts, right? 4 donuts, how many they eat? Which is what, 6%, right? Easy? Last question. What percent ate at most 3?
94.
At most. So let's take a look here. I will mark them in a blue here. At most 3 is everybody else. I could add those all together, but what you might notice is that everybody else excluded what? The 6%. What's the 6%? 4. So it might be easier to say we have got 100 as everybody excluded 6%. Okay? And this leaves us with what? 94%. Is this clear? So your answer is how much? At most 3 donuts. Means they eat 1 or they eat what? 2 or 3. But not 4. Is this clear? So there is more exercises here. Can you please go through this exercise and try to do it? Okay, it needs your solution here. That's your classwork. Okay, and anything that we did not solve here? Okay, very good. This very good, important, very important. Validity. What's the difference between validity and reliability? Can you please read the first paragraph?
What does validity mean? Give an example. The extent to which the results really measure what they are supposed to measure. While reliability is necessary, it alone is not sufficient for a test to be reliable. It also needs to be valid. For example, if your scale is off by 5 kilograms, it reads your weight every day with an excess of 5 kilograms. The scale is reliable because it consistently reports the same weight every day. But it is not valid because it adds 5 kilograms to your true weight. It is not a valid measure of your weight.
Okay, so I'm trying to measure your weight. Okay. To measure your weight correctly, first you have to have the right measurement. You go and you get me, for example, measurement tape, and you come and tell me 165. Did you measure my weight?
No.
You measure what?
The height.
So is this valid measurement?
No.
No, it's not valid measurement. Okay, now let's go for reliability. Can you please read the reliability?
What does reliability mean? Give an example. Reliability is about the consistency of a measure, accurate, precise figure, the extent to which the results can be reproduced when the research is repeated under the same conditions.
I ask, is your measurement reliable? I want to measure the weight of each student in the class. And you bring the weight and you put it here, the scale, called scale. You came and you weigh yourself. First time you weigh yourself, 100. I said, please sit down, rest for 5 minutes, and then come back, measure yourself again, because I suspect that this is 100. You go back, you measure your weight again, you find your weight is 120. Is the scale reliable?
No.
How come? 5 minutes, you sit down, you gain 20 pounds or 20 kilo? That's not possible. So the measurement, it's not reliable. Something wrong with the scale. So if you are using the scale for the entire class, then the entire result is not reliable. You cheat, the scale is not correct. Okay? So do you know the difference between validity and reliability now?
Yes.
Okay. Now, let's take a look at a few examples. Can you please read the first example?
Yeah, you measure the temperature of the liquid sample several times under identical conditions.
What's mean identical?
Above.
Yes.
The thermometer displays the same temperature every time, so the results are real.
So every time you measure the temperature, it's the same. So that means what? Reliable. You can trust it. B, please, B.
The thermometer shows different temperature each time. Even though you have carefully controlled.
Controlled. What's mean controlled? Okay.
To ensure the sample temperature stays the same. The thermometer is probably functioning and
Malfunctioning. What's mean malfunctioning?
Not working correctly.
Not working correctly. So, therefore, the measurement is what? Is not valid. يبقى الميجرمنت هنا is not valid. You don't have reliability here because the measurement is not valid. Okay? Okay, next one. C. I need someone to read. Please read.
A doctor uses a symptom questionnaire to diagnose a patient with a long-term medical condition. Several different doctors use the same questionnaire with the same patient but give different diagnoses. This indicates that the questionnaire has low reliability as a measure of the condition.
Do you understand this one? Okay. D. I need someone to read D in the back. Tfadal.
If symptom questionnaire results in a reliable diagnosis will answer at different times and with different symptoms. The answer that it has high validity as a measurement of the medical condition.
Again, if symptoms, what mean symptoms? Yes. The symptoms questionnaire resulted in a reliable diagnosis when answered at a different times and with the different doctors. This indicates that it has what? High validity. Okay, you go to the same doctor, another doctor after 10 minutes, another doctor, and you have the same questionnaire, right?
That's me.
They said you have cold. Each doctor say you have cold. That's mean what? The questionnaire itself, it has validity that they are all of them. They diagnose your illness is cold. Is this clear?
Yes.
What's the time now?
42.
Okay. So here another explanation for reliability and validity. Please go through this table, okay, and test yourself again the difference between population and sample. I think we already did this before, right?
Yes.
And we did the representative sample, right? And the answer is here written. What is unbiased? Neutral. What's mean neutral?
Objective.
Means equal opportunity.
Yes.
Are you biased or unbiased? If I say each one of you have equal opportunity to win this bottle of drink.
Unbiased.
Unbiased. But if I say I'm going to give him 2 chances in the same poll, that's biased. It's clear because he gets one more chance extra. Okay. Okay. And we talked about validity, right? The answer is written here, right? You need to write the answer for this down. Okay. Same thing. It's just repetition. What is frequency? What is relative frequency? What is relative cumulative frequency? How to use, I identify RF and RCF. Okay, all this we covered. Okay, very easy. How can you do descending order? How can you do descending order, ascending order? Okay, how to make relative frequency table? Very easy, right? Very simple. The following data scored 30 students in a mathematics class. The score is out of 25. Scores obtained out of 25 by 30 BMU students of mathematics class in the examination are given below. So they're giving you the result of the students. Represent the data as a group data taking the class interval 0 to 5. I'm giving you a hint of how to solve it here. Okay? So all you have to do is just group them like 0 to 5. But first you have to put this put the data in what? In ascending order. After this, count the number of data to match the original given in the exercise. Divide the interval to an equal number class as per required, 0 to 5. So you start 0 to 5. The next one is going to be what? 5 to what? 10. And the next one will be 10 to what? 15. Next one?
15 to 20.
15 to 20, and so on until you reach the end. What is the biggest number here? 24. So the next one is going to be what? 20 to 25. That's it, right? Because up to 24. Okay? And then you count how many from 0 to 5. How many in the numbers? Of course, you're going to put this in order, right? And then you put the values here, the frequency. How many? Okay. Count the frequency to each interval class. Oh, see, it's written here. The answer 5. Now you need to get the second one. If you have 5 to what? 5 to 6?
1.
Well, 5 to 10. Change this to 5 to 10. Okay. And that's here how much?
10 to 15.
10 to 15. And then
15 to 20, and then 20 to 25.
20 to 25. Is this clear? And if you don't know how to solve it, the answer is there. Okay. Another example here. Read the example and try to solve it. Okay. Make tally. Another example. Okay. More examples. Okay. That's it. So we are done with today's lesson.
Yes.
I'm giving you something for fun. What is this? Crossword. Please look for the word and find a word in there. Have a good evening. See you next class.